Graph and polynomial functions and models. So we are going to graph this using intercepts, multiplicity, zeros, and then turning points. That's how we graph polynomial functions. So everything we've been finding up to this point, it's important because that's how we're going to find everything we need to graph polynomials. Before we get started, we're going to change this just a little bit so we're not working with fractions. Have that read 3x plus 3, and then we'll have x minus 2. I just didn't want to have you guys work with a fraction. This way we create a whole number and we don't have to work with fraction. Alrighty, so the first thing that we need to do is determine the end behavior. Alright, so end behavior, that's how it's going to act after we graph it all. Where are the arrows going to go? So to find your end behavior, there's actually a really simple way to do it. I'm going to rewrite our function. You actually don't need to multiply anything out. You don't have to FOIL. You're going to have to multiply, excuse me, but you won't have to FOIL. So I wrote that twice because it said x minus 2 squared, so that's why I wrote x minus 2, x minus 2. Now, the end behavior, what that is, it's how it's going to look like at the end. So to find that, you're going to multiply the first term in every factor. So you're going to multiply the first term. So we'll have y equals 3x times x, times x times x times x, and we get 3x cubed. So that's our end behavior. Now what that means is when we end up graphing this, the ends will look something like this. So that's what the ends will look like. Whatever's in between is in between, but the ends will go down and then up. So it's going to help us graph it. Alrighty, part B. Let's find our intercepts. So we have two types of intercepts, x and y. Let's first find the x and then we'll find the y-intercept. To find the x-intercept, we make y equals 0. But it's already factored, so we just set each factor equal to 0. We'll have 0 equals 3x plus 3. And then we have 0 equals x minus 2. You don't have to write it twice because we just know 2 repeats itself. So we don't need to write it twice. Remember, all that little exponent of 2 tells us is the multiplicity. So we'll get to that. Let's go ahead and solve for our intercepts. We subtract 3 to both sides. We have negative 3 equals 3x. Divide by 3. We get negative 1 equals x. And then here we just have to add 2. So we get 2 equals x. That means we have two x-intercepts. One at negative 1 and another at 2. So let's go ahead and find our y-intercept. Y-intercept, we actually have to put in the work. We have to make x equals 0. So we have y equals 3x, which is 0, plus 3 times x minus 2 squared, and the x we're replacing now is 0. So we have 3 plus 3 is 6. 0 minus 2 is minus 2. And that's going to still be squared, so we have 6 times 4, which is 24. I thought my dogs were getting in something. Alright, so our y-intercept is 24. Positive 24. Alrighty. Let's go ahead and determine the zeros and the multiplicity, then whether each zero crosses or touches the x-axis. So part C. We're talking about zeros. Remember, our zeros, those are just our x-intercepts. So we have two zeros, one at negative 1 and one at 2. So negative 1, it has a multiplicity of 1. How do I know the multiplicity is 1? Well, there's always a little 1 right there. There's always a little 1 right there. So that's how I know it's 1. So since it's a multiplicity of 1, that's odd. It crosses at -1, 0. What do I mean by it? The graph. 2, it actually has a multiplicity of 2. Since it has a multiplicity of 2 that's even, it touches at 2, 0. That is from 5.1, ETOC. Alright, we found our zeros, we figured out where they cross our touch. Now all we need to do is find our turning points. So part D, remember turning points, that's degree, which we say represents n minus 1. So the degree of this polynomial is 3. So we have 3 minus 1, which is at most 2 turning points. So the graph shouldn't turn like 10 times. That'd be weird. It can only turn at most twice. This is all we need to graph our polynomial. Intercepts and behavior, whether it crosses or touches. Turning points is more of like a guide, but for the most part, this is all we need. So I created just a blank graph for you because I want to show you that we don't need to have a huge 24 by 24 by 24 by 24 graph. We can make it work for us. So my x's, I'm going to make 1 through 3. The reason I do that because my x value, the biggest x value I have is 2. So that's why I do that right here. My biggest y value is 24. So I'm just going to go all the way to the top and put 24. Awesome. And then on my bottom, I will just go to -24. Doesn't matter. I can do whatever I want for the graph. As long as it makes sense to me, as long as it works for the information I have, you can do it. So what we're going to do first is plot our intercepts. So we have 2 of them at -1 and 2. I'll explain crossing and touching in a second. We have our another y-intercept at 24. Those are all of our intercepts. Awesome. Now we graph this. So if we're trying to graph this, if we look at our graph, we're reading left to right, remember? So there's no point over here. There's no point on this in quadrant 3. So that's why we're going to go directly from this direction right here. Then we go up to our point, and you see how at -1, it's supposed to cross at -1, 0. It does cross at -1, 0. We go to 24, then we go back down to our another intercept. At 2, 0, does it cross or touch? At 2, 0, it touches, so we're not going to cross. So we touch it, and then we go back up. How do we know where our arrows go? Because of our end behavior. We know that at the ends, we have one that goes down and one that goes up. So that's how we know this is coming from down to get to our next point at -1, 0. We cross it because of its multiplicity. We go to 24, go back down. We only touch at 2, 0. Then we know to go back up because of our end behavior. Alright, I'm going to show you how my math lab is going to have it look. So this is my number 7 on my math lab. The numbers are going to be just a little bit different for your number 7, but not too much different, okay? So we have to figure out part A, which is the end behavior. So the end behavior is, remember, you multiply out your first terms. So if this is part A, I'm going to do it right here in blue. So technically we have y equals x plus 4, x plus 4, x minus 5, x minus 5. And then to get our end behavior, we multiply all of these. So we have x times x times x times x. So that's why we have x to the 4th. Now we find our intercepts. So you find your intercepts just like how you would. I'll do it in pink over here, part B. So to find our intercepts, we do x minus 4 equals 0 and x minus 5 equals 0. So we have x equals 4 and x equals positive 5. Sorry, I wrote down that wrong. x plus 4, so we subtract it to get minus 4. And that's where we get our intercepts. Your y-intercept, remember, for your y-intercept, you just make x equals 0 and solve. And when you do, you get 400. Alright, this is where part C, you determine the zeros of the function and their multiplicity. So remember, the zeros are literally just your x-intercepts. So we just copy it over, negative 4, 5. And now it's going to be here, the lesser 0. This is going to be a thing you're going to have to fill out. So the lesser 0 is a 0 of multiplicity 2. So how do I know that? Because the smaller number that we are working with is negative 4. So that comes from here, x plus 4 squared, so that's why the 0 has a multiplicity of 2. Since it's even, we know it touches. This part right here is going to be a drop-down menu. So you either pick touches or crosses, and since it's even multiplicity, it touches the x-axis at negative 4. So that's where we got that negative 4. So it goes, what's the multiplicity? Does it cross or touch? Then what x is that? Our next x-intercept that we have is positive 5. That's the greater 0. The greater 0, the bigger number, it has a multiplicity right here. That's where it came from. So it came from x minus 5 squared. So it has a multiplicity of 2. So the graph, since it's even, it touches the x-axis at 5. Your turning points, remember, that's just degree minus 1. So n minus 1. So 4 minus 1 is 3 turning points. When you graph it, you match the graph to the information you have. So 3 turning points, that is it. So B and C, those aren't 3 turning points. So we don't use B, we don't use C. Those are only 2. So it's either A or D. Now, you match up the information you have. Also, look at your end behavior. Your end behavior states, since it's even and it's positive, it's going to go up and up. This one goes up, then up. D does not go up and up. Also, we can also prove it to you, because here, our y-intercept, let me zoom in a little bit. Our y-intercept here is 400. So that does match with what the information we have. We also have x-intercepts at negative 4 and 5. So this would be negative 4. This would be positive 5. And they both touch at those points. Not cross, they touch. So that's how we will know A is our graph. Alright, let's practice this again, not on my math lab, but this is how it's going to look exactly like on my math lab. So just follow the direction in the video and on the notes, and you'll be able to totally get through it. Alright, let's analyze the polynomial. So analyze just means graph. So the first thing we need to do is determine end behavior. And remember, end behavior is the first terms multiplied out of each factor. So let's separate it first. We'll have x plus 1, x plus 3, x plus 3, and then x minus 4. X plus 3 is squared, so that's why we wrote it twice. So to find our end behavior, it's going to be all of the first ones multiplied, so x times x times x times x, and then we get y equals x to the 4th. So that means our end behavior, it's going to go up, then up. Whatever's in between is in between, but the ends will go up and up. Alright, let's find our intercepts. So x-intercept, we just set each of these equal to 0. So we have 0 equals x plus 1, 0 equals x plus 3, and 0 equals x minus 4. So we have negative 1 equals x, negative 3 equals x, and 4 equals x. So those are our x-intercepts. We have them at negative 3, negative 1, 4. Order doesn't matter, but it's appreciated, so put them in order. Alright, next we have our y-intercept. We just make x equals 0, so we plug it in. We have y equals 0 plus 1, 0 plus 3 squared, and 0 minus 4. So we have 0 plus 3 is 3, 3 squared is 9 times negative 4. So we get negative 36. Alrighty, part C is asking where they cross, where they touch, all of that goodness. So part C, we have 3 zeros. We have negative 3. We have negative 1. And we have 4. So negative 3, it comes from here. And the exponent is 2. So negative 3 has a multiplicity of 2. Therefore, that's what 3 dots mean. Therefore, it touches at negative 3, 0. Alright, our next one is negative 1. Negative 1 came from here, and since there's no exponent, it's actually a 1. There's always always a 1. So it has a multiplicity of 1. Therefore, it crosses at negative 1, 0. And last but not least, we have our third multiplicity of 4. So that came from x minus 4, and since there's no exponent, there's always a 1 there, so it has a multiplicity of 1. Since it's a multiplicity of 1, it crosses at 4, 0. That's all we need. Oh, my bad, turning points. I mean, turning points are helpful, so you know you're not messing up. So turning points, we do n minus 1. So 4 minus 1, so 3 turning points. Alright, that's all we need to graph. So let's go ahead and plot our zeros and our y-intercept. So our y-intercept, we have negative 36. So I'm just going to make that negative 36 all the way at the bottom. And then for zeros, it goes negative 3 to 4. So I'm going to make each x go to 4. And then I'll make the top 36. Alright, my intercepts that I have, we have 0, negative 36. We also have 3x intercepts at negative 3, 0, negative 1, 0, and 4, 0. And then we have our end behavior. End behavior says we go up and up. Since that is the case, our end behavior states we go up, then up. We can't do that, because is that going up? It's not, right? So it's coming from the top. Also, at negative 3, 0, do we cross or touch? We touch at negative 3, 0. So then anytime you touch, you kind of just make a little boop, go up, and then go back down. And you are 100% correct by doing that. You just make a little, like, hump, and then go back down. At negative 1, 0, it crosses. So we're going to cross to get to negative 36, and obviously that makes sense, right? Because that's our next point. Then we make our way over to our next 0 of 4, 0. And at 4, 0, it crosses. So it crosses, and now we have our end behavior. See how it goes up, then up? And there is our graph. The question after this about the calculator one, I took it out of here, and I took it out of the notes. I took it out of your homework. It's not even on the test. I never test you on it regardless. I feel like it's just really hard to do calculator via remote, and if we were in class, it'd be a different story. But we're going to stop here, and that is our video.